Rational or irrational numbers? Rational numbers, when you read that in the name of something, indicates that it's going to be a fraction problem. The definition of a rational number is anything you can write as a ratio of two numbers, where a ratio of two numbers is just like a fraction. 1 to 7, 1 over 7. So, when we're talking about rational numbers, we're writing about anything that can be written as a fraction. Well, if I can count fractions, I can also count mixed numbers, right? If I have 1 1/3, I can change that to 4/3 into a fraction. I can also count my whole numbers. If I have 3, I can put it as 3 over 1. I made it into a fraction. Well, if I can count my whole numbers, I can count things that are square roots that are perfect squares. The square root of 25 is 5, and I can then put it over 1 and make it into a fraction. I still have other things that are rational numbers. Terminating decimals. Well, what in the heck's a terminating decimal? A terminating decimal is one that ends, like 0.25. 0.25 we said was 25 hundredths, and now I've just written it as a fraction. And the other kind of rational number you're going to have are repeating decimals. A repeating decimal, that 0.3333333333, although it's difficult or more difficult to change it into a fraction, hopefully you know it's a really common one. It happens to be the fraction 1/3. If you take 1 divided by 3 on your calculator, it's going to show 0.3333333333 on your calculator. So it's a repeating decimal. All of those things are included in your rational numbers. Irrational. Irrational numbers are non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals. An example of something that is irrational is the math symbol pi. Pi is the value you always get when you take the circumference of a circle divided by its diameter. Pi is, if you use your calculator and you hit Shift and the button that has the pi symbol above it, which says EXP, it's way down on the bottom of your calculator. So if you hit Shift EXP, you should see the pi button on your calculator. If you hit equals, you see you have 3.14159 ... and you get a decimal number that never ends and never starts repeating. So it doesn't go to 33333 or something like that on the end. It's non-terminating and non-repeating. So anytime you see something with pi, it's going to be irrational. The other way you're going to get an irrational number is to have a square root that is not perfect. If you did the square root of 2 on your calculator, you get 1 point ... and a whole bunch of numbers after that, and they don't stop and they don't repeat. So, only 2 ways you're going to get irrational numbers. What I would do is look at my list first and look to see if I have these 2 things. If they are there, they're irrational. If not, they're probably in this list on top. So I'm going to look and I say, oh, this one has pi in it. I know anything with pi is irrational. Then I've got a couple with square roots. Square root of 21. If I try to do the square root of 21 on my calculator, I'm going to get a big long decimal number. It's irrational. However, if I do the square root of 25, the square root of 25 on my calculator just gives me 5. 5 is a nice whole number. It's going to be rational. Now those were the only 2 things I had on my list. Pi and the square root of something that's not a perfect square. The rest should be on our other list. 26. 26 is a fraction. That's what a rational number is. 30.39 with the bar means it's repeating. Repeating decimals are rational. So if I look at number 11, same kind of thing. I'm going to look for my irrational ones first. Pi. This one here has pi in it. I know it's irrational. Then I look for my square roots. 16's a perfect square, but 11's not. If I do the square root of 11, I get a big, long, crazy decimal on my calculator. It's irrational. The rest, here's my square root that is a perfect square. I would get -4, which is a nice whole number. This one's a fraction. We know all fractions are rational because that's what a rational number is. And then we have, again, a repeating decimal. Repeating decimals are rational. So I'm going to move the board. If you don't have this written down, pause the video for a minute. And then we're going to pick out our rational and irrational numbers on the next one. So again, I'm going to start with my irrational numbers. Irrational numbers, anything with pi. Here's something with pi. That's irrational. Square root of something that's not a perfect square. Again, the 11 is not a perfect square. If I do that on my calculator, I get a non-terminating, non-repeating decimal. I then look and I say, here's a square root, but it is a perfect square. That gives me -8 if I do it on my calculator. 8 is a whole number, which is rational. Here I have 28ths. 28ths is a fraction, which is what a rational number is. Here I have a terminating decimal. It ends. It doesn't keep going on forever. Terminating decimal I could write as -16 32/100ths. So I can make that into a fraction. It is rational. So rational and irrational numbers.